Cool. So we'll be looking at the contains duplicate problem. Given an integer array of nums, return true if any value appears at least twice in the array, and false if every element is distinct. So let's copy that over. So let's talk about the question first, and then get into how we're actually going to code it up. So we know that the input is going to be an array of nums, so integer nums, and we also know that we need to return true, right? So we know that the output is going to be a boolean, right? And let's see, if a match exists, we return true, and then else we return false. Cool. Let's do the brute force method first. We're going to do for each number. So for each number in nums, we're going to do a for loop, and then we're going to start at the very next cell that we did in TwoSum. So for let's do second. Let's call it second. Second in nums, and all we're going to do if number is equal to secondNum, we'll return true. And if we don't match, we go ahead and continue, because we don't want to return false, because we want to make a check at every single combination. So we need to do that at the very end. So it's not till the very end that we'll go ahead and return false if we didn't find any actual pairing. So this is a brute force method. Now let's go over the time complexity real quick. This is going to be O of n, because you're going through each element within your array, and then the subarray, the inner loop, is also going to be O of n. So then this search right here is going to be O of n squared, where the complexity of the time it takes will scale exponentially in relation to the number of elements you pass in. Right? Because for this, usually we want to take the worst case scenario. So the worst case is always that you won't find the match until you get to the very last number with the very last pairing. Yeah, let's get into it. Let's go with the brute force method. So let's see. Yeah, we'll return false at the very end if we don't have it. So let's see. The first part we're going to do, we need this part right here. For each number in nums. So for integer iterator equals 0, iterator is less than nums.length, and we're going to do plus iterator, right? So that's plus 1. Okay, and then we need the inner loop. So integer iterate do second equals to the iterator plus 1, because we don't want to have the same number. We want it to be 1 to the left of it. 1 plus 1. Let's do second is less than nums.length, and once again plus second. Cool. This seems about right. So then we just need to do the check here. So if let's see, nums add iterator. Remember, the iterator is the position in the cell, not the actual value of the array. So here we're passing in, we're saying in the array, I want the number at this spot, where here we're just saying, hey, this is the number, right? So remember, we have to pass it in to get the actual value. So if numbers at iterator is equivalent to numbers at second being the second position, we will go ahead and return true. And then at the very end, we're going to do is just return false. So let's see, let's copy these over. Cool. So it's, and then, yeah. Cool. So these are all the lines that we typed up and said this is what we're going to write for the actual pseudocode. And then here is just the other return statement where it return false. And this only triggers if no match found. Cool. And okay, let's go put that into LeetCode and see what we get. So we're gonna go ahead and copy this over and hit paste. Okay, and let's hit run. Hopefully I didn't make any syntax errors, but it should be fine. Perfect. Cool. Let's hit submit. Let's just see what we actually get in terms of speed. Oh, time limit exceeded. Yep, here it is. Perfect. Right? Perfect example why these are bad. Right? You see this giant list? So while this code works for a list this huge, right? Like, it seems just going from 0 to 9999. So because of the time complexity of this, as we stated, let me just go back to the other IntelliJ. So because of the time complexity we actually put here, what's going to happen is it's actually taking, let's see, 1, 2, 3, 99,999 to the second power, basically instructions, and right, worst case, and that's that's an insanely huge number. So it makes sense why this timed out, because the amount of like time this is going to take is so large that I don't think it's supported, because this is in no shape or form a viable solution, right? So while one of those examples where while the code in essence makes sense and you can see what's actually happening, why time complexity matters so much, because a number this large is insane. It's such a slow algorithm that it doesn't make any sense to even have it this way. But cool. I think it's one of those where it's just better for learning and actually see what's going on, get a better idea how to use these structures. But now let's go on to an actual feasible solution that's way faster than this, shouldn't time out, and it's still pretty easy to understand once you understand this one. Cool. Here is the contains duplicate, the fast way, right? So if we watch the two sums one, you know, this part should be pretty straightforward. If you haven't, just a quick refresher how this works. So we want to know if a duplicate exists within the array. We're going to parse through the array still with the for loop, but we need to keep track of every value we've seen, right? Because instead of, it doesn't make sense to say, hey, I'm going to start at this value and then go through every other subsequent value and check if it exists. It's a lot easier to think of, okay, cool. Okay, pretend you're in a library, right? And let's say you're gonna check if you can find a copy of a book on a bookshelf. Instead of saying, here, I'm gonna start the first book, check every other book. Nope. All right, second book, check every other book. Nope. Third book, check every other book. That's super, super slow. It's essentially what we're doing. It's a lot easier just to make a list and say, hey, have you seen this book? Nope. All right, add to the list. Next one, and just keep going. That way, we're gonna do a one pass. So it's gonna be a one pass, and let's see. Let's do. Let's do. Should be a set. For this one, should be a set. On the previous one, we used a hash map because we wanted to have a key value pairs, right? A value and a key. We don't really care because we don't need to know how many times we've seen it. If we've seen it at least one time, you know, it's good enough. So we'll create a set. So we'll have a set. We'll call it seen books. Seen books. Right, and basically all we're gonna do is for each book in bookshelf. Each book in the bookshelf, all we're gonna do is we are going to go ahead and say if we've seen the book in the book, done, else add book to list. Cool. And then at the very end, if we didn't find any pairs, all we're gonna do is say return false. Return false. False, and done, return true. Return true. Cool. So pretty straightforward. Then we just set up the variables and we'll walk through the code and then how to think about it and maybe do a run or two. I'm just gonna copy over the code from our comments and then see what the actual code we need. So we'll create a set of the scene books. In our case, the scene values. I guess I could also call it scene ints. That's a little bit easier. Integers. And we have that set to a new hash set, brand new and empty. And the way hash set works is basically you just add values, and if you ask it, hey, does it contain this value, and it'll just basically say yes or no at O1 speed, which is insanely fast. But we'll get into that right now. So next part in our pseudocode was for each. Okay, so for each book in the bookshelf. In our case, it's for each number. So for integer iterator equals 0, iterators less than nums.length, nums.length, and plus the iterator. Okay. And cool. So now we need to see if the book exists in the actual bookshelf, which we did here. Cool. So the way we're gonna do that is we're gonna pass in each value into the hash set and ask, does it contain it? So we're gonna do if, another if statement, if seen integers dot contains, and we're gonna pass in now the value we want us to check. So it'll be nums, and we're gonna pass in iterator, which will be the position. And then if it does, we've seen it, we're gonna go ahead and return true, because we don't need to return the pair or the value because it wants a boolean. So here we'll return true. And then else, we need to, now here's the other part where else we have the book to the list. Cool. So this one's still pretty simple. So it'll be seen integers dot add for this one. Add, and then nums, the iterator, and that should be all. And then at the very end, it will return false. If we want to do a small little modification, not in terms of speed, but in terms of readability, we could do this. We could do integer. We could do right integer. Current value. Value is equivalent to nums at iterator. Cool. And then that means we could replace these with this one. Cool. So then we just, cool. So this should all work. So first we create a set of seen integers. It's empty at the beginning. And then we're gonna go and do a for loop through each integer in the list. And then we'll get, then we'll create a variable called current value set to the current integer we have. Then if in our set of integers, if we have the integer we currently have, we return true. If not, we're gonna go ahead and return false. All right, pretty straightforward. So let's say the array we have passing in is like 1, 2, 2, 1 to 1, just to be simple. Right, so the first loop can be equal to 1, and then current value is gonna be equal to 1. And does it contain it? Does seen integers contain 1? No, it does not, because it's empty at this spot. So we put empty, or I can put an empty one like this. So we're gonna add it to the list. So now seen is going to have 1. All right, it's time for the next loop. So on loop 2, the value is 2. This is now going to be set to 2. Have we seen 2 in the list? Right? No. So once again, no, but this time because the list only has 1. So now else we have the book to the list. So at this point, seen is now gonna have these 2 values here. Now the third time, it's 1. Current value is 1. Do we have it in the list? Yes, because the list right now is 1 and 2. So we're gonna go ahead and return. Return true at iterator equals 2, because that's where we're at 1, 2, 1, and it's gonna be 0, 1, 2. Cool. That should be pretty straightforward. Let me copy it to the LeetCode and see how we do. Cool. So we're back in LeetCode. Let's run it before we submit just to make sure I didn't do any syntax errors, but we should be fine. Cool. Perfect. Let's hit submit and hopefully it works. Cool. Perfect. And it seems like 10% submissions. I beat 29% of users. 10 milliseconds beats 88% users. So this Java solution is faster than 80% of users who have submitted. Cool. Any questions, comments, or concerns, leave a comment down below. If there's any question you want to go ahead and ask, again, down below. And cool. See you next time. I'll see if I make a video on basically the biggest thing I see developers not doing. Yeah, cool. See you guys next time.